So this is the 11th video on friction. So in this video also, I'll take up a numerical problem on kinetic friction. Okay. This problem is from Krotov. Okay. It's a Russian book. You must be knowing it, Mir publishers. I'll take that problem from Krotov here. Okay. First I'll write down the question. Fine. Question is this. A block can slide along. A block can slide along an inclined plane in various directions. If it is given a certain speed u down the inclined plane, its motion is uniformly decelerated, and it comes to rest after moving a distance L1. Okay. If it is given same speed u up the incline, it comes to rest after traveling a distance L2. Rest after moving a distance L2. Okay. At the bottom of the inclined plane, a perfectly smooth horizontal guide is fixed. Smooth horizontal guide is fixed. Okay. Find the distance L covered by the block over the inclined plane along the guide if it is given an initial speed u in horizontal direction. Answer should be in terms of L1 and L2 alone. Answer should be in terms of L1 and L2 alone. Alright, fine. This is the question. this is the question. Fine. Alright. And I'll rub it. Okay. I'll draw the diagram of the situation and then I'll solve the problem. Okay. So I'll draw the diagram of the situation. So this is the solution. Solution is this. Okay. So this is the fixed rough inclined plane. It makes some angle with the horizontal which is not specified. Here assume this angle to be theta just for the sake of calculation. Or here a smooth guide is fixed like this. This is the guide. Okay, this is a smooth fixed guide. Which is horizontal, okay. Here there is a small block which can slide over the inclined plane in various ways. Okay, now when it is given a speed u down the incline, it covers a distance L1 before coming to rest. When the same block is given a speed u up the incline, it moves a distance L2 over the inclined plane before coming to rest. Now question is, when the same block is given a speed u along the guide, then after moving what distance L will it again come to rest? Answer, L should be in terms of L1 and L2 alone. Okay. Now this problem you must first note that from where to start to begin to solve the question. That is the most crucial issue. Okay. So let us start from here itself. Okay. Suppose the speed is given a speed u along this guide. Okay. Fine. Alright. Now while the block is moving along the guide, smooth guide, I'll draw its free body. I'll draw the free body of the guide. Okay. I'll draw the side view of the free body. Okay, I'll see from this side. Okay, so from this side, if I see from the side view this side, how will it appear? Situation, it appears something like this. See, this is angle theta. This is the side view of the guide. Block is given a speed u in this direction. Okay, so this surface of this guide is smooth. Only this surface is rough. So this is the block. This is the block. I draw its free body. Okay. 1 mg, okay, fine. This guide will exert some normal force N on the block up the incline, okay. This rough inclined surface will exert a normal force N1 on the block in this direction, okay. Now this surface is given to be smooth. Surface of the guide is given to be smooth, but this surface is given to be rough. Let us take the friction coefficient here to be mu. Okay, fine, alright. So now here this is the 3D side view, this is the 3D view of the situation. Okay, fine, alright. Now what I do, I first determine its acceleration. Now see, mg has a component down the incline, mg sin theta, and is just equal to mg sin theta, equal in magnitude, opposite in direction, because the block has no acceleration in this direction while moving along the guide. Okay, fine, alright. Now this N1 will be how much? See, if you draw this N1, if you take a component of mg normal to incline will be this one, mg cos theta. Okay, fine. And here the friction coefficient has been assumed to be mu. Alright, fine. Now I see, while the block is moving along the smooth guide, it is accelerating in reverse direction. It has say some reverse, it has deceleration of magnitude say a. Deceleration has a value of a. Okay. Now what I do, I first determine the value of a. Fine. So while it is moving this way, friction on this block due to the inclined plane is in this direction f. Okay. In this friction I have not shown in this diagram. 3D view, it's a side view. In this 3D view, the friction on this block will act in this direction while it is moving along the guide. Okay. So it will be accelerating in reverse direction. It will have deceleration in this direction. Okay. So now net force in this direction is simply F, that is equals to mass times acceleration. Okay. Now what about F? F will be written as mu times N1. I hope it is clear. Mu times N1 is equal to Ma. That means mu, what is N1? Mg cos theta. Okay. Is equal to Ma. Mm cancels out. So this is the deceleration of the block, which is constant. Okay. Now it has been asked that what distance L will it move before coming to rest. Fine. Now you have this one. Okay. So it has initial speed u in this direction. Its deceleration is a in this direction. It is constant. So when it covers the distance L, its speed becomes 0. So I apply that formula, v square equal to u square plus 2ad. Now v becomes 0, u is u. In this direction, u is the positive direction is taken to in this direction, a is in reverse direction. So instead of a, I write here minus mu g cos theta into d is simply L. Distance moved by the block along the guide before it comes to rest. So L becomes u square by 2 mu g cos theta. Okay. Now we have to determine L. So we must remove this mu and theta. That has not been given in the problem. That I have assumed on my own. Alright. Now how to remove this mu and theta, that is the question. Okay. Now what I do, again I draw the side view of the situation. This is the guide, side view of the guide. Okay. Now the block is initially here somewhere. It is given a downward speed u along the incline. It comes to rest after covering a distance L1. Okay. So it comes here it covers a distance, say how much, say L1. And here the speed of block becomes 0, V1 becomes 0. Now it is given in the problem that in downward journey of the block, its motion is uniformly decelerated. That meaning the coefficient of friction is constant. Okay, only then it is independent of location. It is same at all points. So now during its downward journey, I draw its free body. Mg, okay. Normal force, say, let's call it say N dash. Okay. And friction will act up the incline opposite to direction of relative slip. Mu times N dash, because slipping is taking place. This is the friction F dash. Alright, fine. Load up this one. So, while it is moving downward, okay, at some instant I draw its free body here, mg, n dash and mu n, okay, mu n dash, okay, fine. Now in this case, it is decelerated, so let a1 be its deceleration. So while it is moving down the inclined plane, it is accelerating in upward direction. That is, its deceleration is in upward direction, okay. So let the deceleration be a1. So I apply Newton's second law to block up the incline. The net force of the incline becomes F dash minus mg sine theta, that is same as m times what? A1. Alright, fine. Now F dash is mu n dash. So mu times n dash minus mg sine theta is equal to n a1. Alright. Now n dash again becomes mg cos theta, because block has no acceleration in this direction. So in this direction, net force on the block should be 0. So n dash should be equal to mg cos theta. So mu times mg cos theta minus mg sin theta barabar ma1. So m goes away. So a becomes mu g cos theta minus g sin theta. This is the second equation. First equation was this one. This is the second equation. Now this is seen to be a constant quantity. It is given in the question that its deceleration is uniform. So from here to here I apply the formula v square equal to u square plus 2ad in this direction down the incline. Here speed v1 becomes 0. u square. Again downward direction I take to be plus. So here I insert a minus sign here into L1. Okay. So this means u square is equal to 2a1 into L1. Alright. 2. a1 becomes what? Mu g cos theta minus g sin theta into L1. Okay. So from this it follows that mu g cos theta minus g sin theta is simply u square by 2L1. This is the third equation. Okay. So mu g cos theta minus g sin theta is u square by 2L1. Alright, fine. Now what I do, I consider the downward journey of the block. Okay. And this diagram is a bit, okay. So this equation write it here so that I get more space to write there also. So I get mu g cos theta minus g sin theta is equal to u square by 2L1. This is the third equation I written here. And this I'll rub it now. Now I consider an upward journey of the block. So I draw its side view here. This is the side view of the situation. This is the angle theta. The same block is given a speed u of the incline. And it comes to rest here. V2 becomes 0. After covering a distance, say L2. Now see, while it is moving up, it is slowing down. So it's accelerating in downward direction. So let its deceleration be A2 in downward direction. Okay. So applying Newton's second law to block down the incline during its upward journey. Now what is the forces? Mg, this is N double dash. It is sliding down, so friction acts up the inclined plane. It is moving up, friction is acting down the inclined plane, F double dash. Since slipping is taking place, so F double dash will be written as mu times what? N double dash. Fine. F double dash is equal to mu times what? N double dash. Now while it is moving up, friction is acting down, Mg sin theta is also down the incline, so it is decelerating in downward direction. So what do I write? Mg sin theta plus mu n double dash is equals to n times A2. Alright. Mu n double dash becomes Mg cos theta barabar n times A2. M and n cancels out. A2 becomes g sin theta plus mu g cos theta, which is again seen to be a constant quantity. So it is moving up the incline in a straight line with a constant downward acceleration of A2. So apply that formula v squared equal to u squared plus 2s to this block during its upward journey. Final speed V2 becomes 0. This all have to take any proper sign. Up the incline is plus, down the incline is minus. A2 is in down the incline, so minus A2 into L2. So this becomes A2 is equal to u square by 2L2. Fine, alright. Now I rub this one, okay. Now A2 is how much? Mu g cos theta plus g sin theta, I write it here. So from this equation I write it here now. A2 is this much, mu g cos theta plus g sin theta. Mu g cos theta plus g sin theta is equal to u square by 2L2. This is the fourth equation. Alright. Mu g cos theta plus g sin theta is equal to u square by 2L2. This is the fourth equation. Alright. Now we have to determine this L. So we have to eliminate mu and theta from these two equations. So now see, L can be written in this way. L is equal to u square by 2 mu g cos theta. Now 2 mu g cos theta can be written as mu g cos theta plus mu g cos theta. This way I can write. Okay. This I write it as u square by. Now I write here like this. Mu g cos theta minus g sin theta plus mu g cos theta plus g sin theta. All what I have done is that I have added g, subtracted and added g sin theta, that amounts to 0. Okay, fine, alright. I rub this one. Now see, from this third equation, mu g cos theta minus g sin theta is u square by 2l1. So this becomes u square by 2l1, and mu g cos theta plus g sin theta is simply u square by 2l2. Now u square goes away, cancels out. What we get is this 1 by 2l1 plus 1 by 2l2. This becomes 2l1 l2 by l1 plus l2, which is therefore the required answer. Okay, so it comes to rest after covering a distance l along the guide, where l is equal to 2l1 l2 by l1 plus l2. This is the answer to the required question. Hope it is perfectly clear. Alright, so you go through the problem properly. In case you have some doubt, write it in the comment box. I'll look into it and clarify it. Okay, so this problem was from Krotov. Alright, on next video also I'll take up some more problem on kinetic friction. Okay, so I close it here. Fine.